Everyone is talking about Agentic AI. We know its future, but almost nobody is showing you how to actually build it from scratch. Most tutorials show you a cool demo, but they skip the messy reality of how you get from a simple Python script to a secure enterprise grade agentic AI. I have spent last 2 years building the Eagle platform for enterprise client. I have lived through the bugs, the scaling issue and the breakthroughs. Today I am giving you the roadmap. I have broken down the entire agentic AI journey into 16 distinct steps. Whether you are a coder building your first agent or a CTO deciding whether to spend $1 million, this is the roadmap you need to understand. Let's start. Step 1, Programming and Scripting. Everything begins with execution. Agentic systems are just code. Before you add a brain, you need to build the body. This requires mastering the three pillars of execution. First, Python fluency. Agents are built on logic. You need to be comfortable writing function, loops, handling variables. This is the skeleton of your agent. Second, API literacy. Agents interact with the world via API. You need to master sending HTTP requests, managing authentication headers, and parsing JSON. If you cannot talk to an API, your agent is deaf and mute. Third, async patterns. Agents spend a lot of time waiting for LLM to reply. You must learn asynchronous Python so your agent can do 10 things at once without freezing the application. Think of AI as the brain. This code is the hand and feet. Without it, the smartest model in the world is paralyzed. Step 2. Fundamental of Gen AI, Agent and Autonomy. Grounding yourself in the core concept. Before building, you need to clearly understand the hierarchy, generative AI, agent basic, and the level of autonomy. First, generative AI. We have all used the tool like ChatGPT or Gemini. They are powerful multimodal engine for creating text, image, audio or video, but they are fundamentally passive. They wait for your prompt, then they generate answer and stop. They are assistant. Next, we move to Agentic AI fundamentals. An agent is active software. It operates on a loop. Observe, reason, act. It doesn't just answer, it has a mission. Finally, you must understand the difference between semi-autonomous and fully autonomous agent. Semi-autonomous agents are co-pilots. They draft the email but wait for you to click the send button. Fully autonomous agents are autopilots. For example, they detect a server crash at 3 am, then analyze the issue, fix the code and restart the system while you asleep. Step 3. LLM models and mechanics. This is where you choose your agent brain and frankly speaking, the landscape has exploded. You are no longer stuck with just one provider. For pure reasoning power, you might call ChatGPT, Claude or Gemini. These are your cloud PSD smart model, but they cost money per token. For privacy and speed, you might run open-weight models like Llama 3, Mistral or DeepSeek locally on your own hardware. But connecting these brains isn't just about importing OpenAI. You need to understand the mechanics of using their APIs. Be comfortable with OpenAI style APIs, authentication, secure key handling, function calling, and how request and response are structured. Let the model return the clean structured result in JSON format when you call tools or API without hallucinating. Step 4. Prompting as a code. Prompting isn't just chatting, it is a programming in natural language. The system prompt is your operating system. To get production grade reliability, you must structure every prompt using the 4 layers of context. 1. Role. Define the persona like you are a senior security analyst. This sets the model's baseline knowledge and tone. Second, the goal. Define the task like analyze this server log for suspicious IP addresses. Be extremely specific about the desired outcome. Third, constraint. Define the boundaries like do not flag internal IPs. Be concise. Telling the model what not to do is crucial for reliability. 4. The structured output. Define the output format. Instruct the model to return the result strictly as JSON. This is the most important layer because your Python code need to pass that response. By explicitly defining these 4 layers, you stop getting random chatty answer and start getting reliable response from LLM. Step 5. The architecture or the cognitive ladder. This is where most people get overwhelmed. They try to build a fully autonomous agent on day 1. It breaks and they quit. To succeed, you need to follow the ladder of cognitive architecture. Do not skip rungs. Start at level 1, chains. This is the linear reasoning. You force the model to show its work step by step before giving an answer. It is safe, predictable, and easy to debug. Master this first. Once you have a linear logic down, move to level 2, routing. Think of it as a traffic cop. The agent look at the user intent and decide, is this a refund request? Send it to the billing agent. Or is it a bug report? Send it to the technical support team. This allows you to build a complex system that are still controlled. Finally, you graduate to level 3, autonomous loop, often called the React pattern. This is the expert level. The agent enter a continuous loop, reason, act, observe. It decides its own path and loop until the job is done. This is powerful but dangerous. Step 6. Planning and decomposition. This is the project manager layer. If you ask an agent to write a detailed article and it just starts generating text immediately, it will ramble and lose coherence. To fix this, we implement goal decomposition. Let's look at a simple essay writing workflow to see how a production agent thinks. First, decomposition. The agent split the goal into atomic tasks. For example, research the topic, create an outline, draft the content, and review the output. Second, dependencies. It maps the order of execution. It knows that an essay cannot be reviewed until it has been finished drafting. It builds a dependency graph ensuring it doesn't skip any step. Third, the plan refinement. It's critique the plan before executing. It looks at the outline and task and see if this detail is enough. If not, it adds pseudo step to get more structured plan. By forcing the model to pause and build this blueprint first, you turn a chaotic text generator into a methodical worker. Step 7. Tool use. This is where the AI stops being the brain in the jar and get hands. But how does it work? It is not a magic, it is a specific 3-step technical workflow. First, define schema definition. You define the tool using JSON schema. You tell the model, here is the tool called getStockPrice, and it takes one argument. If you do not describe the schema perfectly, the model won't know how to use it. Second, tool binding. You pass a list of tools to the LLM during the API call. You are effectively giving the agent the permission to see and select these tools. Third, function execution. The model cannot run code, it generates signal. Please run function X. You must write a runtime code to catch that signal, execute that function, and feed that result back to the agent. Mastering this call and response loop is the only way to move from passive advice to active execution. Step 8. Orchestration. As you scale, one agent isn't enough. You need a team, but coordination multiple agents is incredibly complex. You cannot do this efficiently with raw Python loop. To achieve this, we need specialized orchestration framework. This is where tools like LangGraph, CrewAI, AutoGen, and Llama Index comes in. These frameworks are essential because they handle heavy lifting of coordination. They allow you to define specific roles like researcher or writer, manage conversation history between agents, handle the handoff so the agent know when to pass the baton. You simply cannot build a robust multi-agent system without adopting one of these frameworks. They turn a chaotic group of agents into a synchronized multi-agent system. Step 9. Memory. Without this, every interaction Groundhog Day starting from zero. But Real memory isn't just one thing, it has layers. To build a continuous learning partner, you need at least 3 layers of memory. First, short term. Think of this as the agent RAM. It holds the immediate conversation context. What did we just say? So it doesn't forget the question you asked 30 seconds ago. Second, long-term memory. This is the hard drive. We use vector database like Pinecone, Viviate or Quadrant to store document and fact. The agent queries this to recall things from weeks ago, like you prefer Python over JavaScript. Third, episodic memory. Finally, the experience layer. This is where the agent remembers past action to learn from mistake. If it failed to write a SQL query yesterday, it recalls that episodic today and avoid the same error. Building this full memory layer architecture is the only way to stop your agent from making the same mistake forever. Step 10. RAG, Retrieval Augmented Generation. This is how you give your agent a corporate brain. But before we build the pipeline, you need a place to store that brain. You need to get familiar with vector databases, whether you choose Physis, Pinecone, Viviate, Quadrant, Chroma, Melvis or PZ Vector. The goal is the same: efficient storage for data embedding. Once you have your database, you build the data pipeline in 3 phases. First, the ingestion phase, which include multiple steps. First, parsing. Everything starts with parsing. Raw files like PDF, Word documents, Excel, Sheets aren't usable by AI directly. Parser extract messy content and convert it into a consistent agent readable format like clean text or markdown. Second, cleaning. Next come cleaning. We remove noisy header, footer, broken character, duplicated text and irrelevant metadata. This step ensures the model only learns from high quality meaningful content. Third, chunking. Then we chunk the data. Large documents are split into smaller logical pieces using different strategies: fixed size chunk, semantic chunk or structured aware chunk based on heading. This improves retrieval accuracy and keep the context intact. Fourth, embedding. Each chunk then transformed into a numerical representation called embedding. These embedding capture the semantic meaning of the text, not just word. Step 5. Vector storage. Finally, these embeddings are stored in a vector database. This allows the system to perform fast semantic search and retrieve the most relevant knowledge, later forming a long-term memory of the agent. Second phase, the retrieval, which focus on finding the right knowledge, not just similar text. Instead of relying on vector search alone, we use hybrid retrieval, combining semantic search to understand the meaning with keyword-based search like BM25 or SPLAT for precision. This ensures the system retrieves exactly what the user asked for: accurate, relevant, and context-aware. Third, the re-ranking phase is where quality is enforced. After retrieval pulls on top candidate, a re-ranker model rescore them based on true relevance to the query. Low quality or loosely related results are discarded, ensuring the agent only see the most accurate and high signal information before generating the response. Step 11. MCP, Model Context Protocol. Think of this as the USB-C port of AI. Before this, every tool needed a custom integration script. Now we have a universal standard. To master this, you need to understand the MCP topography. It isn't just one thing, it's a 3 distinct pieces working together. First, the MCP host. This is the runtime environment like the Cloud Code app or your own IDE that manage the connection. Second, the MCP client. This is your agent or application. The beauty is that the client doesn't need to know how to query a specific database. It just speaks the universal MCP language. Third, the MCP server. This is where you write code. You build a server that wraps your internal API or databases. Once you build this, it can be plugged into any MCP compliant agent instantly. This shifts your work from building custom integration for every agent to building universal adapter for your data. Step 12. Robustness, the immune system. In production, things breaks. API fails and model output garbage. To fix this, you need to build an immune system for your agent using 3 specific patterns. First, exponential backoff. When an API fails, don't just retry immediately. Wait for 1 second, then 2, then 4. This prevents your agent from DDoSing your own server during a glitch. Second, output parser. Handle the bad JSON problem. LLM often make typo errors in their code output. Instead of crashing, we use output parser that detect the typo or automatically fix the bracket or comma before code runs. Third, self-correction. This is agentic part of the feedback loop. If a tool returns an error like file not found, feed that error back to the agent. The agent reads it and thinks, oops, I made a typo, and tries again. It fixes itself without waking up you. This turns a fragile script into a agentic system that heals itself. Step 13. Guardrails and safety. Think of this as the firewall of your AI. In an enterprise, you cannot just trust the model to be nice. You need to enforce safety using specific architecture like input guardrails. We filter the incoming prompt. We check for jailbreak attempts or prompt injection attack, where user try to trick the agent. If it look malicious, we block it before it even hit the LLM, saving your money and risk. Second, output guardrails. We filter the outgoing response. We scan for PI like credit card number or toxic content. If the AI slip up and generates something bad, the guardrail catches and replace the message with standard response. Third, the tool stack. We do not need to build guardrails from scratch. We use industry standard tool like NVIDIA Nemo guardrails or Llama Guard. These act as the programmable policy layer that sits between your user and your brain. This is the difference between a cool demo and a secure enterprise agentic system. Step 14. Deployment. You cannot run a system from a Jupyter notebook or your local development environment. You need to move from local host to production. We do this by building a deployment pipeline in 3 stages. First, the API layer. Wrap your agent in Fast API, Flask, or use LangServe. This gives your agent a standard REST API endpoint, allowing external application to talk to it securely. Second, the container layer. We package the Python code, the dependencies, and the system tool into a single container using Docker. This guarantees that it works on my machine means it works on production server, eliminating dependency hell. Third, the CI/CD pipeline. Automate the release. We set up a GitHub action every time you push a code change. It automatically run your test, build the container, and deploy it to the production server. No more manual file upload. This is how you turn a fragile script into a scalable production agentic system. Step 15. Monitoring and evaluation. You cannot improve what you cannot measure, but monitoring is vague. We need to build a specific observability stack with 3 distinct layers. First, tracing. We need a X-ray vision. We use tools like Langsmith, Langfuse, Arise Phonics, OpenTelemetry, Prometheus, and Grafana to record every single step of the agent, thought process, and execution. If it fails, you can replay the tape and see what exactly and why it fails. Second, evaluation. We run automated tests. We use framework like DeepEval or Ragas to grade the agent. We ask, did the answer match the retrieved context, or was the tone polite? If the score drops, we investigate and improve it. Third, analytics. We track business metrics. We look at latency, cost, and cruciality sentiment drift. Did the user start the chat happy and end it angry? That is the ultimate metrics. Step 16. Governance and security. This is how you sleep at night. It is not just about rules, it is about infrastructure. You need to lock down 4 critical layers. First, secret management. Never store API keys in code. Use .environment file, config file, secret vault, like AWS Secret Manager or HashiCorp Vault to inject them at runtime. If a key leaks, it rotates automatically, saving you from having a 15,000 bills. Second, identity and role-based access control. An agent triggered by an intern should not have delete permission on your production databases. The agent effectively logs in and inherits the permission of the human user, the PIA reduction. We use tools to scan every packet. It automatically masks name, emails, SSN number before they hit the LLM, keeping you GDPR compliant. For the audit log, you must log every interaction, thoughts and action to permanent record. If things go wrong, you need a legal audit trail to prove exactly what the agent decided and why. So, there it is, the 16-step roadmap. I know it looks intimidating, so don't try to build it at once. Treat it as a step by step. I am going to be doing deep dive into each of these steps in upcoming videos, literally coding them live. So if you want to see that, make sure you are subscribed. Go build something cool. I will see you in the next one.